The Ethics Center is proud to present Disparities in PFAS Exposure and Health Impacts. Our speaker is Courtney Carignan. Dr. Carignan is an assistant professor at Michigan State University with a joint appointment in the Department of Food Science and Human Nutrition and the Department of Pharmacology and Toxicology. She's an exposure scientist and epidemiologist who investigates exposure to contaminants in food, water, and consumer products, as well as effects on reproductive, immune, and child health. She has 20 years of experience working on a range of environmental contaminants. For the past decade, her work has focused on PFAS exposure, health effects, and translation into health protective action. We will have time after the presentation for Q&A, so I invite you to stick around after the talk. And now, please, let's welcome our speaker.
Hi, everyone. Thanks for coming out. Thank you for the invitation and the kind introduction. All right, let's get into it. We're going to talk about PFAS today. Just want to start with my declaration. I've served as a plaintiff's expert witness for water districts in 2 PFAS cases. I did establish my understanding of PFAS well prior to doing that, and it's similar to other independent experts. I also have a bit of a disclaimer, which is that it can be really upsetting to learn about PFAS. And so part of what I try to do in my work is to talk about PFAS in a way and do my work in a way that provides supportive action. So principles like listening first, sharing information and resources, establishing trust and transparency, and trying to be responsive to people's concerns. In general, we find that that seems to be helpful for communities and people who have these kinds of exposures. And the opposite kind of action of not having transparency and people feeling like they're not being responded to tends to increase people's stress. So just wanted to say that, and happy to talk to you about how stressful PFAS is. Anybody wants to do that. I also wanted to tell you that I help organize the National PFAS Conference, and this is designed really centered around communities to help bring the science to them in an accessible way. And we record the conferences and we put them up online so you can actually watch all our speakers from all of our past conferences, including the one in 2022 in Ann Arbor. 2024 in Ann Arbor. I also help develop and manage the PFAS Exchange, which is an online resource that has lots of information about PFAS, and again is really designed to be supportive of people affected in the communities. And I'm going to show you a bunch of information today, and if you want to get an email with it, because you can't keep up with all the QR codes, just use this QR code and send me your information. I'll send you an email. You can also opt to be on my email list. I don't send many emails, maybe a few a year. So one of the reasons I was asked to come today is Kalamazoo has PFAS in its drinking water, and I'm going to talk to you about the past contamination in the parchment drinking water, and that it's very expensive to address these issues. It's been expensive for water, the water utilities, and everyone. Okay. All right, so what are PFAS? So PFAS are a class of more than 20,000 chemicals used widely in many products to provide stain, grease, water, and fire resistance. So I've listed some of the products here. See some pictures. It's certainly not comprehensive, but they're just used in a whole lot of different products that we use every day. They have a very useful property, and that one end likes water and the other end repels it. And so this is the property that really makes it useful. That carbon-fluorine bond that really characterizes PFAS, the other property that really characterizes PFAS, is very strong, very stable in the environment, and very difficult for our bodies to eliminate. Their extreme persistence has earned them the name forever chemicals. PFOA and PFOS, which are called C8 because they have 8 carbons, were phased out of use over a decade ago, but hundreds of other PFASs are currently in use, and there's mounting evidence that these chemicals are also harmful. All right, so just to give you an idea of what some of these different structures look like, what the different PFAS families are, it's a little bit of an alphabet soup, so I'm not going to talk too much about all the different kinds of PFAS. but just know that there's a whole lot of them. Hundreds to thousands of PFAS chemicals may have been on the global market at some point in the past 50 years, yet our standard methods only measure about 20 of them. So one of the things that PFAS chemists and other PFAS scientists have been doing, one of the things that we've been doing is been trying to sort of measure this dark PFAS and figure out how much other kinds of PFAS are out there that we're missing. I'm not going to talk about that a lot today, but I just want to make sure that I mention it. All right, so PFAS, another thing that makes them problematic is that they migrate very easily from industrial plants and products into our environment, our drinking water, and our food. I'm going to go into a lot more detail about that. So you might be familiar with other kinds of persistent organic pollutants like dioxins, PCBs, methylmercury. They have properties that make them very persistent, like PFAS, but they don't have this liking water, not liking water character to them, so they don't travel in water the way that PFAS does. So PFAS kind of has this trifecta of problematic characteristics of being very persistent, very mobile in water, and toxic. So they bioaccumulate in animals over time, and they biomagnify up the food chain, which means they can accumulate into animals that we eat, particularly the longer chain PFAS, so the PFOA, these legacy PFAS that were phased out, those tend to bioaccumulate more in general. And the shorter chain, which tend to be a lot of the replacements, also parts of mixtures of older mixtures of PFAS, these are taken up into produce. So there's not like a one or the other, it's both, and it's a little complicated. So because they're taken up into animals and they accumulate, they're also found in the bodies of most Americans. We're all born exposed. The developing fetus and infant and children are especially vulnerable during critical windows of development. Babies are born with the same level as their mothers and are further exposed through breast milk. Infant blood levels can rise further after birth from breastfeeding or formula, particularly for formula when it's mixed with contaminated water. So I'm not going to talk about that a lot, but you just kind of keep it in mind. We don't really like to talk about it because it's really sad, stressful, sad thing to think about. But when we're thinking about setting MCLs for our drinking water and things like that, we really need to think about the most vulnerable and how we're protecting them. Okay. So of the hundreds of studies on health effects, almost all have focused on PFOA and PFOS, which are historically the most prevalent. We're getting more on other PFASs now. They've been found to affect multiple systems in the body and have been linked with a wide array of health concerns, including the ones listed here. So I've sort of listed these in order of evidence, strength of evidence. We have a lot of evidence of the decreased antibody response, the effects on cholesterol, so higher cholesterol with higher exposure, decreased infant and fetal growth. So these are small changes in a population level. So they're sort of shifting the population a little bit. So if you have a community that has higher exposures, you would expect to see a little bit of a shift if you use all of our sensitive epidemiologic methods to measure that. Kidney cancer, breast cancer, and testicular cancer, liver enzyme alteration. So PFAS has been likely contributor to non-alcoholic fatty liver disease, affects the liver. Pregnancy-induced hypertension, thyroid disease and dysfunction, and ulcerative colitis. And there's emerging research on other autoimmune diseases that might be contributed to by PFAS exposure. Okay. So a lot of my work involves conducting biomonitoring studies to understand different ways that people are exposed to PFASs, their health effects, and interventions to reduce exposure and improve health outcomes. And I like the sort of exposure pathway figure here because it really centers that human receptor and human exposure, and you can see it's coming from all different directions. You've got exposure coming through drinking water, so if PFAS is in drinking water, especially if it's elevated, that's going to be the main way somebody is exposed. The general population, we think, is primarily exposed through diet. Fish contain elevated PFAS because of the way it's in our environment. PFAS has been used in food packaging, like microwave popcorn. I think a lot of those uses are starting to be phased out. And they're also we can be exposed to our products in our indoor environment as well. But I want to talk a little bit about worker exposure. The exposures I mentioned were all sort of mostly ingestion pathways. So even with products, a lot of that exposure is coming from it being in our dust because it was used to make a carpet stain resistant or upholstery stain resistant. And we all ingest a little bit of dust every day. We can also inhale them. The more volatile PFAS will be in the air. And there's increasing evidence that some PFASs can be absorbed through the skin, which, that kind of exposure is often the last exposure that gets sort of characterized. And I mentioned inhalation. So inhalations can be especially important for workers in the workplace. So I like this figure too, because it kind of makes it a little bit more simple to look at the different exposure pathways and sort of puts it into categories. And I added the worker and the water and food to this to try to make it a little more clear. Right, so if you're in chemical manufacturing or working maybe in chrome plating, you could have high concentrations in the air. So this is showing on the bottom right there, the black pie chart. You see D equals 158, so it's showing a pretty high exposure. And what you can see is that all these other exposure pathways really get dwarfed by that air exposure and that inhalation exposure from the workplace. If you have a high level in water, that's the mostly blue pie chart, then your primary exposure pathway is going to be through your drinking water. And so that's part of the reason a lot of the focus on reducing exposure to PFAS has been on drinking water. And then you see more of that red taking over the pie chart as we get lower levels in water, and that's the general population is mostly exposed through diet. And this is kind of an older study, so this is probably evolving, but I still think it's a really nice way to explain it. All right, so a lot of what we know about health effects of PFAS are from studies of workers and also from the C8 Health study, which is a really big study that took place in West Virginia, where the Washington Work Facility, chemical manufacturing plant DuPont, which made Teflon for use in Teflon pans and other uses. I don't know if you can see it here, but they've got stacks, and the PFAS actually was coming out of the stacks and then kind of like falling down, dry depositing on the communities around it. And so it actually contaminated, I think, 5 water districts, including across the river, in that way. And there's I could tell the story. I'm going to show you where you can watch the story in the movie. But they ended up doing a really large health study. And that's where sort of those probable links of PFAS health effects came from, along with all the other literature. There's very large literature on the health effects of PFAS now. All right. So I also sort of wanted to point out, we don't have a whole lot of studies on occupational exposures. It can be difficult to study workers because it's their livelihood. So doing those studies sometimes have to be more retrospective. But actually, one of the best sets of data that we have for workers is on workers who work at ski resorts waxing skis, because PFAS is in ski wax. And they actually get pretty high exposures because when they're heating up the wax, it's volatilizing and they're inhaling it. So there's been interventions to try to reduce their exposure by using different kinds of ski wax that don't have PFAS in it, but also other like engineering controls to reduce their exposure. This was just me brainstorming other workplaces that PFAS exposure could occur. I want to talk with you a little bit about firefighters. So PFAS is one of the big sources of PFAS in the environment, and contamination to drinking water is from the use of aqueous film-forming foams. So these are foams used to fight fuel fires, and they were sort of required by our government, I think. FAA, was it?
Yeah, it was required by
FAA. Okay. Yeah, it was required for commercial airports and actually was used on all of our military bases, part of their safety protocol. So because of its use there, even just a small amount of AFFF can contaminate a really large amount of groundwater. And firefighters were told that it was as safe as soap and water, and they used it as such. So AFFF has sometimes been called like a witch's brew of PFAS. It contains mixtures of hundreds of different kinds of PFAS. And it's tricky to study because the composition differs by manufacturer and it's changed over time. And so a lot of PFAS chemists spend time mainly are researching all these different formulations and trying to do fingerprinting in the environment to figure out what, where did it come from, who's responsible, essentially. But firefighters can have high exposures because of their use of it, right? So you can see them here using it. And if they weren't wearing SCBA, which it looks like they aren't in this case, about half, I think, of the foam actually doesn't make it to the fire. It's in the air, and they're inhaling it. Almost all firefighters used foam, at least historically, for a week during fire academy training. So we've essentially likely exposed every single firefighter in the U.S. to AFFF, PFAS through AFFF, because of this practice. Another way it was used is in airplane hangars, where they actually, so you can imagine if you had an airplane hangar and there was a fire, a fuel fire, this would be really great for putting it out. It was also a really great way to make really terrible groundwater contamination around where these hangars, where they used it in this way, are located. So here's another picture of a base that's using foam. I've talked to people who have been, workers who have been in the hangar when this happened, weren't wearing any protective gear, and had to find their way out of it, and have questions about how much did I ingest, how much would have been absorbed in my skin, and what kind of exposure would I have had from that. Another old photo. You can see this is on right on the water. So this is just going to go right into whatever water body this is here. People would throw it at each other. They'd have foam parties, even with children. So firefighters who remember this or did these kinds of activities, is very upsetting for them to learn about PFAS and its use in firefighting foam, as you can imagine. So not only, were they exposed in this way, but it also can make it into the groundwater and can be drinking it at the firehouse unknowingly. So if you used, let me show you this slide. If you used AFFF, you were training with it behind the firehouse, you're gonna have very high levels in the groundwater. If you've got a well there, you're pulling up pretty high, your water is gonna contain pretty high levels. You might also be fishing out back. I've talked to firefighters in this situation. You're likely gonna have PFAS in your fish as well, and maybe in your deer. All right. So you can see here, these graphs, the blue one here is the firefighters compared to the general population in Australia and Canada. And this one's showing higher exposure with years of working in firefighting. All right, won't belabor that. You can think about people, workers in paper production having higher exposures. I haven't seen any studies of workers in paper production and their PFAS exposure, but likely it would be elevated, at least historically, before the phase out. Same with textile manufacturing. I don't know if you can see it here, but the PFAS is just like dripping. It's being applied to this textile as a to make the textile more water and fire resistant. And the PFAS is just kind of dripping out of that bin there. It's also been found in school uniforms, menstrual products, like the underwear, period underwear, jackets, like Gore-Tex jackets, and firefighter turnout gear. Work a lot with firefighters. So firefighter turnout gear is treated with PFAS, has useful properties, makes things water and fire resistant. That's great for firefighting. All right, so I helped with this study where we tested never worn gear. This is with Jennifer Field's lab at University of Oregon, right? So we could show that it's coming from the gear and not from a fire. And what you can see is that the newer gear contains a different kind of PFAS than the older gear. So the older gear has this like mixture of fluoroethylamine sulfonates and fluoroethylamine alcohols, which are volatile kinds of PFAS. And the newer one was either almost all 6,2-FTOH or almost all this new PFAS, MEF-BSE, who no one's ever heard of, and we don't test for in blood. And the levels, I don't know if you look at the scale here, this is like going up to 10,000. The levels of the volatile PFAS are much higher than these other kinds of PFAS. So PFOA and PFOS are non-volatile PFAS. The levels in the gear are much, much lower. So there was a lot of focus. See that 2008, you see the teal color? That's PFOA. There's a lot of focus on PFOA and turnout gear. And it turns out that most of what's in turnout gear is other kinds of PFAS that we're not measuring. All right, so if you look at turnout gear compared to other kinds of jackets that you might wear, like a civilian would wear, a non-firefighter, you can see that the levels in firefighting, which are like an order of magnitude higher than the levels that you'd see in those other kinds of clothing. All right, let's talk about chrome plating a little bit. So PFAS are used as a fume suppressant in chrome plating to suppress, to prevent exposure to hexavalent chromium. So metal plating, and there's also chrome plating, both can use PFAS. And there actually just came out this study on workers working in chrome plating in Sweden. And here they were measuring levels of PFAS and heavy metals. And I'm not going to show you the data, I'm just going to show you the highlights. So they found that workers who were exposed to hexavalent chromium were also co-exposed to other metals and PFAS. This was really striking to me. So the PFOS reached extremely high levels, over 2,000 parts per billion. I don't think I've ever seen, maybe other than Sandy, a level that high. Exposed workers had lower mtDNA and longer telomere length compared to controls. They're looking at some health effects. And the exposure mixture was linked to increased oxidative stress and epigenetic alterations. Right, so I'm going to talk a lot about exposure. That's because if you have high exposure, you would also expect more of a burden of disease, right? And if you've got, if you're a worker and you're working in a place where you have other exposures, or you're in a community that's in a more industrialized area, you can have more exposures, and so that's going to, even increase your susceptibility to these diseases even more, your vulnerability. Another one that came out this year is from California, and so a lot of states, including Michigan, have birth cohorts where we've recruited pregnant women, and then we follow them and their babies after birth and look at health outcomes of the children, because exposures that happen in utero and in early life can sort of have effects later in life. So there's a lot of these kinds of studies now. So I think in this one, they were actually recruiting children, so they had 2 child cohorts that they were looking at, and they were looking at PFAS blood levels in the children. And then they looked at how far they were from a chrome plating facility. So they found that compared to areas without chrome plating facilities, neighborhoods with 1 or more than 1 had the concentrations in the blood were higher. Not talking about blood. They had more Hispanic residents, more residents without a high school education, and more individuals below the poverty line. And I don't think this is probably really surprising to anybody, but I think it is helpful to have data on it. And compared to areas without chrome plating facilities, neighborhoods with 1 or more facility, I just said that. All right. So here's the exposure. So here's the concentrations of PFAS in the children's blood, and you can see elevations. So the pink is the category of having more than one or more chrome plating facility within 3 kilometers, and you can see the levels of almost all of the PFAS they measured were higher. I'm doing really good. I'm halfway through my slides. It's 6:30. We're going to make it. All right, so almost a decade ago, I helped author a study where we reported that about 6 million Americans were served by drinking water systems that contained elevated levels of PFAS. And so here in the blue, you can see where PFAS were detected at these elevated levels. The gray is showing where they weren't detected at elevated levels, and then the white is showing where there wasn't any data. And what we found was that public water system contamination was more likely to occur with closer proximity to PFAS industrial sites, military fire training areas, AFFF certified airports, and wastewater treatment plants. So we talked about most of these. I want to talk about wastewater treatment plants. Okay, so in our example of chrome plating, that chrome plater would have PFAS from the chrome plating in its effluent, right? So in this building, if you use the sink or the toilet or anything, that water goes into pipes that run under the ground and go to ultimately the wastewater treatment plant. Companies have the same thing, right? What are you putting down the drain? You could be putting PFAS down the drain, right? There's actually schools where they have PFAS in the wax they're using on the floors that have contaminated drinking water because of the same pathway. Pretty high though, coming from chrome plating. So around the time that I moved here a decade ago, the state of Michigan actually did a pretreatment program to try to get these facilities to reduce the emissions of PFAS into the wastewater treatment plants. Because the wastewater treatment plants are not designed to take PFAS out of the water. They're designed to take the pathogens out of the water. So the PFAS is going to pass right through that into the effluent, which is the water that comes out of the wastewater treatment plant. And that usually is going into a local water body, right? So this is a map of the Huron River, which sort of goes through Ann Arbor. So Ann Arbor was discovered through the EPA's UCMR3 drinking water testing program to have elevated levels of PFAS. That program only tests cities above a certain size, and they did detect it there. So Ann Arbor is one of the first places actually to take action on PFAS in Michigan. And they found elevated levels of PFAS in fish all along the Huron River, and there's fish advisories now, and that got a lot of people's attention. So the other major thing that comes out of a wastewater treatment plant, there's the liquid part and there's the solid part. And the solid part, when it's coming out, is called sludge. And then once it's treated to try to remove those pathogens, it's called biosolids. So if you hear those terms, that's generally, at a high level, how they're different. Right? So some of those biosolids were about a third of biosolids are land applied, about a third go to landfills, and about a third are incinerated. All right, so if you've got PFAS in those biosolids and you're land applying to an agricultural field, they will be taken up into the grasses, into any crops that you're growing. They will move through the soil into groundwater, and they'll be in the dust, and there's also runoff into the river, any local water bodies. So if you've got a farm with a little farm pond, you're going to have the PFAS moving into the farm pond or anything else from those biosolids. All right, so there's a farm outside of Ann Arbor that had like a little boutique cattle operation going on where they were doing this nitrogen, trying to keep their nitrogen emissions down, their nutrient emissions down, so they were sort of recycling their waste on property, but it also ended up recycling the PFAS. So they had elevated levels in their beef, and the state essentially shut them down. And there's a documentary about this, and it's very sad. He's certainly not alone, this farmer. Before him, there were an increasing number of farms being found to have water contamination and crops contaminated and cattle contaminated. So this includes a produce farm in Colorado from AFFF groundwater contamination, a dairy farm in Maine from biosolids being applied to his land, a New Mexico dairy farm, also from AFFF drinking water contamination. This destroyed all of their businesses. So not only is this a big economic impact for farmers, it's also, they've been eating that food, they've been ingesting that water, and so often they have elevated exposures themselves. So in the middle here, that's Fred Stone from Stone Ridge Farm. I met with him this summer. He's been working on PFAS now for 10 years. It's been about 10 years since this was discovered on his farm. And he has all these health effects. The impacts to him and his family have been is astronomical, because he was one of the first to have this happen. So there is something, Maine has been doing a lot on PFAS and supporting farmers. More can always be done. PFAS support for farmers was proposed in the Farm Bill. I don't think that is passed. I feel like I would have heard about that. I I'm still crossing my fingers that that's going to go through because it's really needed. You can't test for PFAS on farms and test for PFAS in their foods if you're not going to have a solution for them. I'll just leave it at that. Okay. So this is sort of showing what I was just talking about, PFAS going from the wastewater treatment plant into biosolids and into the river, and showing what that pretreatment program that Michigan put in place is trying to break that pathway. All right, so I'm showing this just because it helped me really visualize. So if you've got a wastewater treatment plant all over the state, discharging in all these rivers, ultimately those rivers are discharging into our Great Lakes, right? And if you live on the coast, ultimately they're discharging into our oceans, right? The oceans are a lot bigger than the Great Lakes, and so fish in the Great Lakes are known to have elevated levels of all kinds of different pollutants, including PFAS. And so this is looking at PFAS levels across fish, different kinds of fish. And then one of my students put this together of sort of color coding, where we saw exceedances from the literature of fish in the Great Lakes to health guidance, fish consumption guidance. And I helped put this study together a few years ago that was talking about PFAS consumption advisories by state, and they differ, and it just has, the reason that they differ is just on how you do the math. They like, how come here in Michigan, I can eat less fish, than if I were in Indiana? It's not because it's more safe in Indiana, it's because they were doing their math differently. So Michigan actually recently updated their consumption advisories, and they're a bit lower than they were before. And Michigan loves their fish. We have really great guidance here. So there's a QR code there for Michigan's Eat Safe Fish guidance right now, mainly monitoring for PFOS. That's the main PFAS that you're going to see at the highest levels in fish of those that we typically monitor. There's some emerging research that there's other PFAS that could be in fish as well and should be monitored. Okay. The former Woodsmith Air Force Base in Oscoda, Michigan was one of the first sites in the US, if not the first, to identify PFAS and start working on it. So people there will tell you they've been investigating this site for 15 years or something. Maybe it's getting close to 20 years now, because I think I made this slide 5 years ago. The contamination there is massive. So, they put the PFAS out of the hangar suppression system. And I just learned this last summer when I was visiting. They sort of got rid of that PFOS containing PFAS, like the bad AFFF, and they replaced it. And then they did it again. But when the replacement AFFF had PFBS in it. It didn't, and all these other PFASs, right? So it wasn't like, it was maybe a little better, but it still is not a good idea to put into the environment. And so I couldn't believe that happened like not that long ago. Anyways, here's the levels. You can see sort of the arrows, the blue arrows are showing the way that the groundwater is moving, and the colors are showing you how high the levels of PFAS in groundwater are. That yellow squiggly line towards the bottom, that is the Ausable River, which is really famous, actually around the world for trout fishing. And that blue lake at the top, that's Van Etten Lake. I think I usually have little arrows come, yeah. So this is showing where there is a campground and a summer camp. They're right there, sort of where that plume is coming out. And the levels in Clark's Marsh, which is sort of that red area to the bottom, are very, very high. And there's advisories for fish consumption, deer consumption in that area as well. I believe there's fish advisories for the lake. Drinking water, that kind of brownish area is where all the base housing was. So people who lived on base before this discovery, before the base shut down, would have been likely drinking elevated levels, probably pretty high levels of PFAS in their water. They've also been studying PFAS in surface water foam, so as part of this study, also with Jennifer Fields. And what we think is happening, so when PFAS is in a water body, it likes to be at the air-water interface at the top. which is unusual, like for persistent pollutants. You usually see dioxin in the sediments. PFAS can be in the sediments too, but they also really like to be at that air-water interface. So you've got it kind of accumulating on the surface microlayer, and then when you've got wind whipping it up, conditions that would create foam likely anyways, it's sort of facilitating more foam. You can see the foam all over this beach here. And the levels actually concentrating it. So the levels of PFAS in the foam are very high. So in this study, we reported the enrichment factor of about almost 3,000 from the water to the foam. So we crunched some numbers, and the state did as well, and they came out with an advisory to avoid touching or eating surface water foam from Van Natten Lake. Okay, so in 2018, the state of Michigan actually tested all of its public water systems for PFOA and PFOS, which is a really good thing to do because, like I mentioned, the UCMR3 program only tested larger cities. It didn't test smaller municipalities. So they discovered pretty high levels in the drinking water system of Parchment that wouldn't have been discovered otherwise if they hadn't done this testing. And the contamination was linked to a landfill that was like right by, I'll show you, right by the public municipal wells. So those blue dots towards the top, those are the municipal wells, and then that like red dot over here, that's the landfill, and then the other red dot further down is where the paper mill was. Paper mill is closed down, but it's thought that the contamination came from their paper mill waste. Like I mentioned before, PFAS is used in paper making. Okay. So 3 years later, we were able to get samples, or two to 3 years later. This kind of happened during COVID, but by the time we got funding and got out there, COVID was happening, and so our first season we were just getting water and food samples, and then the second year we were able to get blood. So it took us 3 years to get blood samples from our participants. Sort of high-level findings. People in the public water system, on the drinking water system, that was highly impacted. So the concentrations in the water were over 1,000 parts per trillion, which is pretty high. Had levels that were higher than the people on private wells who had lower levels, which is really what we would expect. But this signal is still pretty strong even 3 years later. It's because of the high exposure and because PFOA and PFOS are eliminated from the body relatively slowly. So for PFOA and PFOS, half the level in the body is eliminated every 3 years, or 3 to 4 years. So you would likely have expected these medians to be about twice what they are here if we had gotten out there right away. Right. So part of the point being that this intervention is, going to be effective at reducing exposures, right? So if the half-life is 3 to 4 years, we went out there 3 years after their drinking water intervention, likely the levels were over 100 parts per billion median, which is pretty high. For some reference, like most people are down below around 2. Okay, so when drinking water contamination is discovered, often people will bring in bottled water. In Parchment, they switched the public water supply to the Kalamazoo water supply. If people had private wells, they could get, this is a picture, I think, of Sandy's, maybe that you took, of the filters that get put in the basement near the well. That'll sell like a whole house water filter. It's pretty expensive. And this one on the bottom right is a municipal water system filter. This is for Pease Air Force Base in Portsmouth, New Hampshire. Also very expensive to put in. These systems are typically using activated carbon. Activated carbon is pretty good. So that's like what's in your Brita filter, a pitcher filter. It's pretty good at taking out PFOA and PFOS as long as you're changing it regularly. It's not as good at taking out the shorter chain, more volatile PFASs and a lot of the current use PFASs, including TFA, which is an emerging PFAS of concern and interest. The thing that will take out most PFAS is something called reverse osmosis. You can get it under the sink reverse osmosis filter. It's going to run you around $100, maybe up to $300. It's about $100 a year to change those filters. You might have to change them more frequently if you have more PFAS in your water. And you can't do reverse osmosis on a public water system. There are some sort of enhanced carbon systems now that they've developed to try to get out more of that PFAS, get less of that breakthrough of those shorter chain PFAS. All right. MPART and Eagle have this really great mapping that you can kind of click around and see what some of their environmental data that's been collected around the state is. It's a nice resource. At the national level, we don't have something quite so nice. This is from the Environmental Working Group, and what this is showing you really is actually where testing's been done. So all of those purples, they've tested all of the military sites, but states are responsible for testing drinking water, and so you can see that's pretty unequal across the country. Our PFAS Exchange website has this sort of suspected contamination map, and what you can see is that there's places where they're not testing for PFAS, but it likely is there. Right, so this is important of drinking water standards. Michigan has its own drinking water standards. These are called MCLs. EPA, I think last year, put out federal drinking water standards. This was a really big deal because it was the first time in my lifetime, and I'm kind of old, that EPA set a drinking water standard that is enforceable without congressional mandate. Unfortunately, this year they got canceled mostly. So we don't know what's happening with them, but it was exciting for the year that we had them. They weren't going to go into effect until 2027, so there's that. But the importance of them is that some states have set, and I'm sorry I don't have the map of it, but if you go to our website, we do have the map there. Some states have set enforceable MCLs, and then some haven't, right? So the importance of a federal drinking water system is that we'll get more equitable testing of PFAS in drinking water systems, including the small drinking water systems, and that when it's discovered, they need to actually address it, right? That they have to do something. And then it should also help them get compensation and get money to be able to do something, but that's outside my area. That's what you would expect would happen. All right, so we also did sampling in people's homes. This is a publication where we showed a relationship between levels in these silicone wristbands we had people wear as like a marker of personal exposure in the indoor environment, and levels in serum. And what we found is that it seemed like N-ME fossa, which is a PFAS that we detect pretty frequently in blood, seemed to be coming from, at least in part, an indoor source because of its relationship in the blood with between ME fossae in the wristband and N-ME fossa in the blood. Sorry, it's complicated. My other students really was focusing on local foods, including foods grown in people's backyards. So mostly if you have a garden, you're going to be irrigating it. If that water's contaminated, that contamination is going to be getting into your garden, getting into your foods. So again, this was 3 years after the contamination was discovered. People were watering with clean water. We found that it seemed like the largest prediction of the PFAS in the foods was actually what was in the water currently. So it seems like by doing that intervention and then adding, clean soil to those gardens was really reducing the amount of PFAS in people's produce. It's still there, we can still measure it, but it's likely much lower than it was previously. And the highest PFAS we were seeing was the PFAS that's still in the water, the short chain PFBS. We also saw elevated levels in chicken eggs, not as high as what we saw in local eggs, interestingly, the backyard eggs. So not that many people still had backyard chickens. Some people had gotten rid of them after the contamination was discovered. It turns out, years later, after we studied chickens more, we know that what a chicken is ingesting in terms of PFAS is essentially what's going to be in the egg. And once the chicken stops ingesting PFAS, the levels in their body and their egg will go down pretty quickly, or at least the levels in the egg. So if you find it in your water, you don't necessarily need to get rid of your chickens. The tricky thing is that it's still in the soils and the invertebrates the bugs are taking it up, and we think that's why what we see is in the winter when they're housed, their levels go down, and then when they're not housed, their levels go back up, right? They're out foraging. That's often if you have chickens, you want them to be able to forage if you don't have predator issue. But if you have PFAS in your soil, you're likely then going to have higher levels in your eggs. All right. There's also PFAS contamination in Rockford, Michigan from the Wolverine World War IV tannery. This was discovered, I think, before the statewide monitoring. A lot of that contamination is in people's private wells, and some of those wells are pretty high. All right, and this was from PFAS being used on shoe leather, and the disposal practices were very poor. So there's sort of these landfills all over the town. All right, so families like Tobin McNaughton's family that were drinking high levels in their drinking water have pretty high levels in their blood and their children's blood. So her son Jack's level is shown there as 484 parts per trillion. So I don't know if you remember, I showed you before the sort of water to blood. That was in parts per billion, so I've converted that, 484 parts per billion, still pretty high. And we do that because of this concentration, right? This bioaccumulation from water to blood. It's about a tenfold difference. It's like a whole unit, right? Difference from parts per trillion to parts per billion. And then her younger son, who actually never drank the water, I think she had maybe 2 miscarriages between after having Jack and before having her youngest. So he was only exposed through her, right? Her body burden. And he also has an elevated level. It's so pretty high. All right. So the questions that they have are, what does it mean? Like, how do I protect my family moving forward? I know that this happened. Is there anything that I can do? And their pediatrician's been really responsive. They've done lots of things to be helpful. They've tested the boys' antibody levels. So one of the things that I listed in the health effects was the decreased antibody response, right? So when you get a vaccination, your body creates antibodies to that illness, right? So if it's an illness that nobody's really exposed to, hopefully anymore, like diphtheria or tetanus, we can use that as a marker of the functional immune response, all right? So her boys get vaccinated, they test the immune response, they see it's lower than where it should be to be protective, and then they boosted them. So that's something that some families with these kinds of high exposures have been talking to their pediatricians about. All right, so on our PFAS Exchange website, we have a lot of resources for people to help them learn about these medical screening guidance, learn about how to get blood testing, which currently 10 years ago was almost impossible to get. Now there's a lot of different options, actually, if you're willing to self-pay. The tests run about $300, so they're not cheap. And there's efforts to get insurance to pay for it. New Hampshire actually is one of the places that has legislation requiring insurance companies pay for PFAS testing for people with exposure. Right. We also have this What's My Exposure tool, which you can put your water data in, or you can put your blood results in. It will give you this sort of contextualized report that shows you where you are compared to the general population. So here on the right, that orange dot is the person's level, and those blue dots are showing sort of the distribution of the population. And then it's showing you where the median is, like where the central is. So you can see this person's level is a little bit above sort of the average for the general population. So we have noticed disparities in people's ability to get blood testing and their ability to get doctors to talk to them about medical screening the way that they talk to them. So Hope is somebody who has a exposure from a military site, and again, one of the early ones that was discovered. And she has this quote that really, I think, is very eloquent. So she's talking about how she'd go to the doctor, they wouldn't really know about it. They would kind of make her feel small. They made her feel stupid, embarrassed even for asking about it. So because of this feedback we've been getting from people in these communities, we've been doing a lot to try to help doctors learn more about PFAS so that when somebody comes to them with questions about it, they have a place to go where they can learn more. We also have companion guidance documents so that people can bring them to their doctor, and then they have the information right there and the resource right there. Because usually the doctor's got like 5 minutes or something, and they need to know what to do really quickly. And this is something we're continuing to work on. So we do have this free CME for clinicians, so they can take this course, they get credit for it. It's very comprehensive. It has actually features a lot of community members that we work with, along with experts. So I think it's great. We're doing a study on it right now, so if you know any doctors that or nurses that need CME, have them take it, and then they can also be part of our study and give us, so we can learn how to improve the CME. All right. There also now is a report from the National Academies of Sciences, Engineering, and Medicine about PFAS, and the thing there's a lot of great things about that report, but one of the most useful things is this figure. So most people are going to fall in that 2 to 20 range in terms of levels in blood, and basically recommendations, I know it's really small, is basically what you get when you go get your annual physical. So it's not anything sort of above what a doctor would normally be doing. If it's above 20, there's some additional things. Again, I'm sorry it's small, but I'm going to make it bigger. Actually doing cholesterol testing in children, which normally isn't done, doing thyroid hormone function testing, assessing for symptoms of kidney cancer, including you could do a urinalysis for that, and assessing for signs and symptoms of testicular cancer in older than 15-year-old patients, as well as ulcerative colitis. All right, so Sandy is another resident of Rockford, also with very high levels in her well. She's always like, it's not a competition, but my levels are the highest. She learned about her water contamination a year after her husband Joel passed away of liver cancer, very suddenly and unexpectedly. So she has a story about how she took her PFAS blood levels to her doctor, and her doctor was very responsive, and he said, oh, that's really interesting, let me learn about it. He had to put it in her chart. So she talks about PFAS blood test, if you've got a high exposure like this, kind of being like when your doctor asks you about smoking, right? It's another risk factor that your doctor can put in your chart and might help might help them with a diagnosis later. So when she came to him with some unusual symptoms, he said that he was able to diagnose her thyroid cancer faster than if he hadn't had that in her chart. So there's an op-ed on her in Environmental Health News, and we like to share that story with her permission, of course. There are some ways to get PFAS out of your blood more quickly. One way is through plasma donation. So this is from a study of firefighters in Australia, and they found in the study that doing plasma donation actually got it out of your blood faster than just doing a regular kind of blood donation. So if you are using this to try to get your PFAS levels down, you might want to opt for plasma. I also heard recently if you go to a place that will pay you for your plasma, that they are likely going to filter it in a way that would get out of the PFAS. It's hearsay. I heard this from another scientist who I trust, but I haven't witnessed that myself. So I'd love confirmation of that if anybody works in plasma donation and knows what kind of filtering they do. Because a lot of people who have high levels and would like to get it out of their blood are concerned about the ethical implications of donating like PFAS containing blood. What most doctors will say is that people need the blood. This is a life-saving donation that you're making, and don't worry about it. But I think it's an ethical question and leave it up to others to sort out. Sandy also helped found the Great Lakes PFAS Action Network, and they're doing a lot of work to advocacy around PFAS to try to help communities get what they need in terms of testing and exposure reduction measures and health supportive measures for PFAS. And you can join, so that's what I'm telling you. I mentioned before the conference. Registration is opening soon. There is a travel award that people can apply for. It's a limited number of them, but we do pay for some community members to attend through the travel award process. And so this is the National PFAS Contamination Coalition. It's a really great group of folks, people affected by PFAS across the country. So it's like 1 or 2 people per community. A lot of these people have their own local action group around PFAS, and they also participate in the national group as well. And this is Rob Ballot, who's the lawyer featured in Dark Waters. So he's sort of the lawyer who discovered PFAS in West Virginia. The story about him is really interesting. Basically, a farmer from the town where his grandmother's from called him with this concern about his cattle dying and saying, you know, I sold landfill, like part of my property is a landfill now for DuPont, and then all my cattle started dying and nobody will take my case. Can you take it? And he thought, he being an environmental lawyer, he thought this was gonna be an easy case. And he's still working on it like 20 years later. He's been one of the people to really advance action on PFAS. The story about him is really interesting. Doesn't really go into the science, it's much more about the drama, and it's an interesting story. No Defense is about Escoda. The Devil We Know is like a general documentary. And then there's a whole bunch more. Toxic Farmlands about the farmer in Michigan that I mentioned. The Forever Chemicals is about the community in Rockford that I mentioned. Sludge is about the farmer in Maine that I mentioned. Burned is about firefighters in turnout gear mostly. You know, they're not done by necessarily experts all the time, and so sometimes there's stuff in there that's a little not as accurate. So in Burned, there's a mention about it's not the PFAS, it's not the PAHs, it's the PFAS. It can be both, right? You can have multiple bad exposures that will make the cumulative exposure and health effects worse. Firefighters are exposed to a whole range of harmful things. It's well known. Firefighting is actually listed as a carcinogen and by IARC. There's a lot of efforts right now to try to address the epidemic of firefighter cancer. The one in the bottom left is about North Carolina, which is where the Gen X contamination is from, that I didn't talk about. But basically, we phased out PFASs, the legacy PFASs, and then they kept being produced. And one of the places they kept being produced is in Chemours, which is smack in the middle of North Carolina. They contaminated all the land around them from this atmospheric deposition, and then it went down the Cape Fear River, and where it lets out is in Wilmington, and Wilmington gets their water, their public water, from the river, and so it had high exposures to PFASs for decades without knowing it, most recently to these replacement PFASs. And they had to fight for years and years and years to get water treatment. They finally did, and they talk about the kind of water treatment they have to do is like football fields worth of activated carbon. Very expensive system, very well engineered. All right. The only more about PFAS tomorrow. The Great Lakes PFAS Virtual Summit starts. Great Lakes Virtual PFAS Summit starts. Registration is only $35, and you get full access to everything, so you don't have to watch it right at that time. You can watch it later. My group is presenting on Wednesday on our infant. We're doing modeling to look at infant exposures, and what it really shows, spoiler, is that infant exposure goes down when you do interventions like Michigan did to have MCLs, test water, and make sure that these communities aren't drinking contaminated water. The levels in breast milk are generally higher than what you have in formula, even when there's water contamination. And if you have water contamination, the breast milk levels go up, right? So that intervention, to the whole population is going to protect moms, babies, families, and that's really, we can really demonstrate that when we look at those exposures. All right, this is my lab, this is our funding, and this is our team for the PFAS Exchange. Oh, this is our team for PFAS United, and thank you.
So do you feel comfortable?
Yeah, thanks for, I hope I didn't go too long, but any questions?
Courtney, how was the method of exposure to the silicone wristbands? What could you explain?
Yeah, so, like a Livestrong silicone wristband. So we take those, Heather, my chemist collaborator, extract them so they're clean, put them in clean foil, and then we have our participants wear them for, I think it was a week or two. And then they give them back to us, put them back in the foil, put it back in the bag, and we analyze it. So the PFASs will, if they're in there, they're going to come up and they're going to absorb to the silicone. So it's a way of measuring sort of what you would be exposed to in the environment, like what's around you, and maybe also if you're putting on lotions, or we know PFAS can be in certain kinds of makeups like mascara. Actually, from that study, we found that women who wore makeup, and particularly who wore more mascara and it was foundation, had higher levels of PFAS in their wristbands.
So the silicone is like a magnet in some ways, but is it just stuff clings to it then?
Yeah. Yeah, so those more volatile PFASs, those will. So some chemicals like phthalates also, there's sort of this like air to skin pathway where it's going to deposit on your skin, it's going to be attracted to your skin and going to be absorbed through your skin. That could also be on your hands if it's not being absorbed and you'd be ingesting it. So it's a way to sort of look at what's in somebody's environment without having to like put a little air pump on them, which is usually not convenient. It's very convenient where it's easy. Yeah. Yes.
So you said that the older PFAS has been phased out, but now there's kind of like newer versions of it that's still getting really used in products. So part of me is thinking, well, why? How do we know that these are bad? Has there been any movement to get some of these things off the market?
Yeah, so PFAS Central is a website that has a list of suppliers like Keen Footwear that are moving away or have already moved away from PFAS. So there's sort of like a product list where you can go to find PFAS-free things. I really should have like a standard slide of all the things. But I think part of the reason I don't is because there's things that probably really make a big difference. And then there's just this things you can't do much about. And that's probably a lot of what our exposure is coming from. So things like making sure your drinking water doesn't have PFAS in it, not using Scotch Guard or those kinds of products. Don't spray that around your house or near your face, or probably at all. What am I talking? Don't eat microwave popcorn until we know what on earth they're using in those papers. When I buy products, I'm not buying anything that says it's stain and water resistant because I think it's probably going to have PFAS in it. I think they stopped manufacturing carpets with it, so most new carpets shouldn't have it. What else do I avoid? I avoid so many. I have like a PhD on what to avoid, essentially. Gliding floss is made with PFAS. Maybe not anymore, but it certainly was in the past. Careful about where I eat my fish, where you get fish from. There's only so much you can do about that, though. Like grocery stores, you're not going to know exactly where it's from, usually. And all fish has PFAS in it. So I just try to eat a balanced diet, spread it around.
Yeah, it's not like it's on a label. You can't look up PFAS on the label. You just have to kind of like alert to these properties, really.
Yeah, so, yeah, you asked why are they still used? They're used because they're in products that are profitable, right? People will buy them. There's not usually not a label. More people know about PFAS now than they did 10 years ago, but most people don't know about PFAS. And scientists around the world have written about, the need to sort of essentiality rule of only using PFAS where it's essential, because there are products that are life-saving that are really needed, and we don't have a safe replacement for yet. And a lot of states have been passing various kinds of legislation to try to restrict or ban PFAS in certain kinds of consumer products. So there's definitely efforts to stop the use of PFAS. One of the tricky things is sort of this, like, how are you defining it? I didn't talk about fluoropolymers, but there's an effort to try to say, well, fluoropolymers are different from other kinds of PFAS. They're fine. We know that fluoropolymers use PFAS in their production. They often have side chains that will come off in our PFAS. And, can you really guarantee that if you're making fluoropolymers, you're not emitting PFAS to the environment? So sort of the safe substitution is the preference. You know, how do you do the R&D? How do you sort of move society in that direction? But it's an uphill battle. So that's the story. We kind of call it regrettable substitution. I think someone's trying to coin a new term because they've said it's not regrettable because some people know. Most of us kind of know you're moving from a chemical with a property that's useful to another very, very similar looking chemical, but we don't have all the data on yet. You're not going to be super surprised when it's also harmful, right? So we see this with the bisphenols, so BPA to BPF to BPS. BP. The phthalates, we've seen them from certain phthalates to other kinds of phthalates, from certain kinds of flame retardants to other kinds of flame retardants. It keeps us very busy doing our research, right? Like I can always move to the next chemical within a class even. But it's really demonstrating a failure in our chemical policy, right? That you can't do that with a pharmaceutical. You can't say, oh, this pharmaceutical is problematic. I'm just going to try this one until we find out it's not safe. So it's sort of like safe until proven guilty kind of thing. It's not that there's not the laws. It's that we are not able to enforce them, right, the way that they were intended, and that companies can get around it. So one of the efforts is educating companies to say, like, you know, you're going to be exposed to this stuff too, and consumers want companies that are responsible and aren't going to use these chemicals. Yes.
All right, so we're kind of famous for the lead in the water plant. Did that event and all the publicity that has come with that, because there seems to be a lot of focus on, we're replacing all the lead pipes and all that kind of stuff, because we're experiencing that in Kalamazoo pretty much on a daily basis all over the city. Did that help your cause when that happened to draw attention to what's really in our water, or is it?
Yeah, I think it helped. I think part of the reason we've seen so much action in Michigan on PFAS is because of Flint. We might not have seen, when your governor, when the people in charge are paying attention for whatever reason, and the money flows, right, into the jobs of the people who then are being told you should do this, right? And if that's not happening, it's kind of the bottleneck often in government, is that you've got a bunch of people, or maybe not a bunch of people, not well funded, that have a job and they want to do the job, but their higher ups aren't telling them to, or they're not giving them what they need to be able to do it, telling them that they can, they're not going to get in trouble, they're not going to get fired, and that they have the resources to do so, then those protections that we all think we have aren't happening. The things that you would expect to happen won't happen. And I think what helped Michigan flow, in a sense, was Flint. Yes?
So what effect are you seeing from the change at the top at the federal level with grants being cut and obviously EPA being cut back and all that kind of stuff? Have you seen some negative effects of that at this point?
Yeah, so I was talking about farmers needing solutions. So there had been a big EPA call for funding, and a whole bunch of scientists were funded and were starting to get underway, had hired people, and then those all got cut as part of that big budget cut we saw happen earlier this year. A few got them back, but I don't know, I'm gonna make up numbers, but like if there were 10 of them, 2, right? So I lost a grant that was looking at PFAS and other PPCPs and biosolids, and movement up the food chain and human exposure. Fortunately, I got it back, but it was a rough few months, and I ended up losing the person that took me years to recruit and had been doing the work, and I ended up kind of losing them anyways. So, yeah, it's been really disruptive, and now there's almost nothing in terms of like those EPA calls aren't coming anymore. It's lean times, I think, right now in research, especially in environmental.
What's the state of the science around that exposure through skin absorption?
There's only a few studies. I don't think it's published yet, but you would expect that the shorter chain PFAS are going to move to the skin more easily. It seems to depend on whether it's a neutral PFAS or an ionic PFAS, which I didn't talk about. So I guess I would say there's not a lot of research, there's a lot of questions, there's potential. Yeah.
It's one of those areas where it's like, gotta do more, sort of longitudinal.
Yeah, dermal research is really difficult. So it's usually last to get done, and like I said, there's no funding. The experts in that in the US, at least, are retired or dead. So there's a few people who can do it. Not many funded, very little. But I think the potential is there. Hopefully it's not a lot of exposure, but I don't think we know for sure.
Has research in general this year just into PFAS oddly? I mean, I don't know, maybe this is beyond what you're prepared to say, but the research in general into PFAS kind of plummeted?
Yeah,
or is it
probably.
increasing?
It's hard to say. I guess I'm not really tracking that. They're like informal, what I hear from my colleagues, what I see in terms of what calls are out. There's sort of like so you might have the momentum, right, of your research and your program, right? You're getting funding to fund a student. It takes 5 years to train a doctoral student. So, right, my first doctoral student went to USDA to work on PFAS accumulation into chickens and livestock. She got riffed. She lost her job, 5 years of training, 6 years maybe. And she had to go to another career path. We lost her to consulting. Almost everybody at EPA that's been riffed at NIOSH, which is our occupational agency, there's almost nobody left at NIOSH. A lot of my colleagues, almost all my colleagues lost their jobs there, have gone into consulting, right? A lot of consulting is working for the responsible party, right? They're not working for us anymore, essentially, all these experts. So not all of them, right? But if you lose your academic experts too, or like the public's not really going to have that much left. States or state agencies seem to be doing better, but they also rely on a lot of federal funding. So, I think what's happening now is not going to just affect us now, right? It's going to affect us for years. They talk about how do you recover from this. It's going to affect us for a long time. Hopefully it doesn't get worse. Yes?
Have you seen in your studies, you're talking about health, obviously, but what about, like with the lead in the water, they were talking about students being stunted in their growth and being behind. Is that the same with PFAS too? Does it have that kind of a effect on students' function and do well in school?
I think the neurodevelopmental effects are not really clear. The literature's one of my students just did a review on it. There's definitely evidence, mostly for motor development. Most of the evidence on PFAS in young children are developing mostly motor development, so it makes sense. So PFAS are kind of like, they bind to proteins, right? And the transmitters all over our bodies are protein, right? So they're binding to this. They also are, are fatty acids, which is like in every piece of every cell. They look like that, right? They've got one end that likes fat and one end that doesn't, repels it, just like these very, very important molecules in our body. So they seem to be disrupting a lot of different things. And the strongest effects in terms of like what's happening at the lowest doses are the effects on the immune system. They're very clearly dysregulating our immune system, or disrupting it. So we see that in children. So we see more illness. So children with higher, on an average, using an epi study, are going to have more colds, are going to have more, illness. Maybe also have more severe illness. So it's not that. I think we're still learning, but we certainly know enough to see these kinds of effects. Trying to think if I'm missing any, the cholesterol effects. So there's a new study that came out looking at NAHLD in children, which is kind of shocking. So I'm not trying to scare you. So I was trying to end on a high note. Did I do that a little bit? Give you some movies to watch?
It's PFAS, it's hard to, I know.
Yeah, I mean, I'm proud of Michigan. I feel like, you know, this is a state that's taking action. Hopefully, that will continue. We've got this conference is really well attended. It's like around the, it's like a global, it has global attendance. I think thousands of people from around the globe attend this thing. It's exciting. Exciting. You like to talk about people. Okay. All right. Well, thank you for coming.
Well, thanks so much. Appreciate it.